Hello everyone, today let's solve the problem, the number of smallest unoccupied chair. In this problem, there are n friends numbered from 0 to n minus 1. There is an infinite number of chairs in this party that are numbered from 0 to infinity. When a friend arrives at the party, they sit on the unoccupied chair with the smallest number. For example, if chairs 0, 1, and 5 are occupied, when a friend comes, they will sit on chair number 2. When a friend leaves the party, their chair becomes unoccupied at the moment they leave. If another friend arrives at that same moment, they can sit in that chair. You are given a zero indexed 2D integer array times where times of I is equal to arrival and leaving times, indicating the arrival and leaving times of ith friend respectively, and an integer target friend. All arrival times are distinct. We need to return the chair number that the friend number target friend will sit on. Let's see this example in order to understand it. We have the times array and we have target friend. Now, friend 0 arrives at time 1. So this is friend 0 arriving at time 1 and he sits on chair 0 because it is the smallest numbered chair. Friend 1 arrives at time 2 and sits on chair 1. Friend 1 leaves at time 3. So here you can see that friend 1 is leaving at time 3. So chair 1 becomes empty at time 3 and friend 0 leaves at time 4 and chair 0 becomes empty. Friend 2 arrives at time 4 and sits on chair 0 because friend 0 has left at time 4, so it is empty for friend 2 to sit. Now our target friend is 1. So friend 1 sat on chair 1, which you can see here. So we will return 1. So this is the problem that we need to solve. First of all, let's see the brute force approach to solve this problem. We will be storing the arrival and leaving time of target friend and store it in target time variable. After that, we will sort our times list so that it is sorted based on arrival times. We will store the length of times in n and we will be creating n chairs because in the question, even though it is mentioned up to infinity, since there are n friends, maximum chairs they can sit on is n, and initially all chairs will be empty. So we will be storing zeros for all the chair times. Now we will be going over the times list and checking some conditions for each arrival and leaving time. Now for each time in times, we will be creating a for loop in order to find the chair that is empty until that point. So we will be going over the chair time now for the first time in times. So for I in range of n, and here we will be checking if chair time of I is less than or equal to time arrival time of our current friend. If the chair time at this particular index is less than or equal to 0, that means that chair is available to sit. And since this chair is available now, we will be updating that chair time with the leaving time of our current friend so that it is available after this particular leaving time. Now we need to check if our time is equal to target time. If it is equal, then we have found a chair for our target friend to sit. So we will return the index, which is nothing but the chair number where this friend can sit. While assigning the chair to a particular friend, if this condition is satisfied, we have assigned that chair to that friend. So once that is done, we can come out of this loop by using break statement. So the loop will continue for the next friend. This is the brute force approach. I hope you have understood this approach. Now the time complexity of this approach is big O of n square because we are iterating the times list as well as the chair time list in order to find the chairs available to sit. And the space complexity is big O of n because we are creating the chair time list with length equal to the number of friends. Now let's see another approach where we will be using heaps in order to solve this problem. In this approach, we will be sorting based on arrival time, similar to previous solution, but now we will be using two heaps. So let's go over this solution step by step. The first step is to prepare to sort friends by arrival times. We will be creating a list called indexes. Now this indexes list will store the indexes from 0 to n minus 1. This will represent each friend's index in the times list. Now we need to sort this index based on the arrival time. We will be using the key with lambda function to sort it based on arrival times. This sorts the indexes list by the arrival times of each friend. The next step is to track chair assignments. We will be creating used chairs list. This list consists of tuples where each tuple is the leave time and chair number. This will help track which chairs are currently occupied and when they will become available. This list is treated as min heap, so the person who leaves the earliest is processed first. We will be creating available chairs. This list will contain the chair numbers that are not currently occupied. Initially, it contains all chair numbers from 0 to n minus 1. This is also treated as a min heap so that the smallest chair number is always assigned first when a friend arrives. The next step is to process each friend in the order of their arrival. So we will be looping over the sorted indexes list. For each index I, we process the corresponding friend indexed by times of I. So we get the arrival and leaving times for this index. This extracts the arrival time and leaving time of the current friend. The next step is to handle friends leaving before the current friend's arrival. We will be using a while loop to check if anyone has already left by the time the current friend arrives. So we will check if the used chairs is not empty and used chairs leaving time is less than or equal to arrival time of current friend. Now for each person who has left, their chair is added back to available chairs by popping from used chairs and pushing the chair back to heap of available chairs. Next, we will assign the smallest available chair to current friend. We get the smallest available chair by using heap pop available chairs. This assigns the smallest available chair to the current friend. And now this chair is occupied by our current friend. So we will push this chair into our used chairs. So after assigning a chair, the friend is added to used chairs heap used chairs along with their leave time so that the chair can be released when they leave. And at the end, we check if the current friend is the target friend. If it is true, we will return the chair assigned to the target friend. Now let's see an example walkthrough in order to understand it. So we have the times list and target friend. We will be sorting friends by arrival time. The sorted indexes list is 0, 1, and 2 because the arrival times are already sorted in this example. The next step is to process friend 0. So friend 0's arrival and leaving times are 1 and 4. We need to assign chair 0 to friend 0 as all chairs are available at the beginning. And we will be adding the leaving time of friend 0 and the user chair as chair 0 into our user chairs list. Next, we will process friend 1. Friend 1's arrival and leaving times are 2 and 3. And we assign chair 1 to friend 1 now because chair 0 is already occupied. And we will add the leaving time of friend 1, that is 3, and chair 1 to our user chairs. And here we can observe that friend 1 is the target friend. So we will return 1. The time complexity for this approach is big O of n log n because we are sorting it, and updating heaps is also log n operation. The space complexity is big O of n because we are creating different lists, each with size n. This is the entire code. I hope you have understood this approach as well. That is all in this video. I will see you in the next one. Till then, keep coding.